Welcome everyone to the next lecture on kinematics. Uh, in this lecture, we are going to cover average velocity, differentiation, and instantaneous velocity. So we covered up till this example that if a particle is following a path x is equal to t square, where t is in second, we have to find the displacement of the particle between 0 second and 2 second. So we did this last time. So today we are going to start with these unsolved questions. A particle follows the path x is equal to 2 root 2 meters. Find the average velocity of the particle between 1 second and 4 seconds of motion. So as we know from the definition of average velocity is displacement upon time interval. And to find the displacement of the particle, we have to write what is the final position and what is the initial position of the particle. So the initial position of the particle, the initial position of the particle is 2 root 1. By substituting the value of t equal to 1 seconds in the value of x, we get x is equal to 2 root 1. So that is 2 meters. The final position of the particle is 2 root 4 meters. That is 4 meters. So the displacement of the particle, which is final position of the particle minus some initial position, is 4 meters minus 2 meters. That is already 2 meters. And when we divide the displacement by time, we get 2 by 3 meters per second. Next question. A man starts from origin and goes root 2 meters southwest. It turns east and proceeds by 1 meter. The complete motion took 1 second to come about. Find the magnitude of the average velocity of the man. So first let us draw the axis. So here we have chosen this axis and this axis. So these are the two axes which we are talking about. Let's say this direction is some east, this direction is east, this direction is north, then opposite to north we will have south, and opposite to east we have west. So when it is given that a particle is traveling in southwest direction or southeast direction without mentioning the angles, then we have to assume that the particle is traveling along the 45-degree angle line. So in many of the questions we have done, it was mentioned that we had to travel some 30 degree north of east or some 30 degrees south of west. But when the direction is not mentioned and it is simply given that the particle is traveling along southwest, then we choose the 45-degree line along which we have to get displaced. So we have to travel a distance of root 2 meter in southwest direction. So we draw a vector which is root 2 meters long, and we chose southwest direction. Now we know that this angle is 45 degree and this distance is root 2 meter. So after coming at the final point, the question says that the particle or the man turns east. So the man turns east and then it proceeds by a meter. It travels a distance of 1 meter. So to travel a distance of 1 meter, it would be something like this. So if we calculate a little bit, you would see that this distance is root 2, and the distance which it has traveled along the west direction, the distance which it has traveled along the west direction, this particular distance is root 2 cos 45 degree. This distance is root 2 cos 45 degree, which is 1. Since cos 45 is 1 by root 2. So it has traveled 1 meter along west direction, and after covering this distance, it has traveled 1 meter along east direction. So that means that after completing the motion, the particle would come to this particular axis to this particular axis after it has completed the motion. So eventually the particle has traveled only this much distance. Only this much distance the particle has traveled. This distance is root 2 sine 45 degree. So root 2 sine 45 degree is again only 1 meters. So the particle has traveled a distance of 1 meter, or its displacement is 1 meter, and it has taken 1 second to complete it. So this is the average velocity of the particle. You can also say what is direction. This direction is some minus j gap or towards south. Question 3 is to be skipped. We'll do it after completing instantaneous velocity. So let's jump to question number 4. In question number 4, it is given that a car goes from A to B. It takes 10 kilometers to cover this distance. When it comes back from B to A, so it takes 10 minutes to complete the journey. So the total distance covered by the car is simply AB plus AB, that is 20 kilometers, and the total time taken is some half an hour. So this is 40 kilometers an hour. So this is the average velocity of the car for 2 dimensions. Oh yeah, average speed of the car. Total distance upon total time. This was the average speed. Now for 2 dimensions, how do we define average velocity? So for average velocity in 2 dimensions, we choose the v vector and we put these crochet signs. These signs are crochet signs. So these signs represent the mean of the value within those symbols. That means if we put crochet signs around velocity, then we mean mean velocity, which means average velocity. So this is the symbol for average velocity. So the average velocity is defined as displacement of the particle divided by time interval. So the final position vector minus initial position vector divided by the time interval of the particle is equal to the average velocity. So let us try to apply this. So again the definition is the same as the previous one, except that now we have to use the vectors instead of just putting the values of x. So the final position vector minus the initial position vector divided by the time interval. So a lizard moves from A 1, 2 to B 3, 3 on a wall in 10 seconds. Find the average velocity of the lizard, assuming it follows a zigzag path. So we know that the average velocity is independent of the path of the lizard. That depends upon simply the initial and final positions. So let us write the initial and final positions. The final position RF of this lizard is 3, 3, that is 3i cap plus 3j cap. The initial position of the lizard, that is Ri, is I cap plus 2j cap. The displacement of the lizard delta R is final position minus initial, that is 2i 3 minus 1 plus 3 minus 2 j cap. So the average velocity vector is 2i plus j, displacement upon time interval 10 seconds, meters per second. So as you can see, the definition remains the same, except that we have to just use the vectors for average velocity in these cases. Okay. Next, we have a car which moves 100 kilometers southeast. Then it turns north and travels 102 kilometers and stops. If the whole motion from start to end took 2 hours, find the average velocity and the average speed. Uh, so, as is given is that the particle has traveled some distance in southward direction. So first, the east direction is this one, and north is this one. So southeast is somewhere here, and it has traveled a distance of 100 kilometers. After traveling a distance of 100 kilometers, it travels a distance of 100 kilometers in north direction. So eventually, to calculate the average velocity, we have to find the overall displacement, that is this particular vector. So we can do analytical addition of these two vectors to find what this distance is, how much is this distance, and then proceed from there. So to do that, it is important in some scenarios to understand what is the angle between two vectors. Uh, like in this case, we have 100√2 and 100, these two vectors. So, what is the angle between the two vectors? That becomes the question, because the magnitude of the vectors are already known. So, what we do is that this particular distance is some 100, and if let's say the particle has turned some northward after traveling southeast 100 kilometers, then the angle between these two lines, as we discussed earlier, when a particle travels in a southeast direction, it means an angle of 45 degrees. That means this angle is going to be 45 degrees. This vector is in this direction, and this vector is vertically upwards. So this angle is also going to be 45 degrees, which means that this angle is going to be 135 degrees. This angle is going to be 135 degrees. So when the vectors are aligned like this, then the angle between the vectors is actually the direction, the angle between the direction of the vectors. So the direction of the vectors is here and here. So the angle between these two vectors is the obtuse one and not the acute one. That means the direction in which the vectors are pointing, the angle between those directions is to be taken. So this vector is pointing in some this direction, and the other vector is pointing in some this direction. So the angle between these two vectors has to be some 135 degrees. So while vector addition, we use 100 square a square plus b square plus 2ab cos 135 degrees. So this whole quantity, this whole quantity would come out to be some 100 kilometers. So this distance is going to be 100 kilometers. So two sides of this triangle which we have drawn are equal. So that means that this angle and this angle are 45 degrees. That means this angle is also going to be 45 degrees. So that means that the particle has eventually traveled a distance of 100 kilometers along northeast direction. So the average velocity would be the displacement of the particle, that is 100 kilometers. The net displacement of the particle is 100 kilometers divided by the time taken, 2 hours. So the average velocity is 50 kilometers an hour. The average speed for the motion of the particle is the total distance covered upon total time. So the total distance covered is 100 plus 100 to 2 divided by the total time taken by the particle, which is 2 hours. So this complete average speed is going to be 50 1 plus root 2 kilometer per hour as is calculated. The next question. A ship travels with a speed of 10 km per hour along 30 degree north of west for 2 hours. It then changes its direction to west and travels with a speed of 10 into 2 minus root 3 kilometers per hour for 1 hour. Thereafter it turns south and travels with a speed of 5 km per hour for 2 hours to a point C. So what the ship has done is that it is traveling in water. It is traveling with a speed of some 10 km per hour along a direction 30 degree north or west. So how do we find 30 degree north or west? We choose the west direction, and from the west direction we turn 30 degree north. So this direction is in which the ship is going to travel initially. Now it has traveled a distance. It is traveling with a speed of 10 kilometers per hour for 2 hours. So it has traveled a distance of 10 into 2, that is 20 kilometers. So the distance traveled OA, it is already written, it is 20 kilometers. After that, it travels a distance of 10 to minus root 3 kilometer per hour for an hour. So we multiply the speed with the time. So this is the complete distance which it has traveled. So to demonstrate that, let's jump on to another figure which is drawn ahead. So it is given to us in the question that you have to travel a distance of 20 kilometers along this 30 degree north or west, and then you have to travel with a very peculiar speed, that is 10 into 2 minus root 3 for 1 hour. So then we travel along this direction, west direction, and we travel along the south direction. So let us ascertain what these vectors are. So to find these vectors, we simply try to write what are the displacements. So we know that the distance OA is some 20 kilometers, and we have to write the vector. So the vector OA would be simply 20 kilometers, and the direction in which it is traveling, which is minus cos 30 degree. Since along x-axis we are traveling along negative x-axis, this is the negative x-axis which we are traveling along, minus cos 30 I cap plus this direction which is sine 30 j cap. So this would come out to be this much, minus 10 root 3 I cap plus 10 j cap. So this is the displacement in first phase of motion. In the second phase of motion, the particle was moving with a speed of some 10 to minus root 3 kilometers per hour. So it traveled with a distance, it traveled for 1 hour. So into 1 hour would be this much only. And we have traveled a distance along negative x-axis. So that is 10 to minus root 3 and a negative sign in front of it. That is delta R2 vector. So the first part or second part of the questions are, we have to find the total velocity of the particle average velocity of the particle between points O and B. So that means we have to find the displacement of the particle between the points O and B. So to find the displacement of the particle between these 2 points, we simply add these 2 displacements, delta R1 and delta R2. So when we add delta R1 and delta R2, we get minus 10 root 3 I cap plus 10 j cap plus the delta R2 displacement. So when we are adding these 2 displacements, we get minus 10 into 2, that is minus 20 I cap. And you would see that k minus plus 10 root 3 and 10 root 3 simply cancel out. So this is the terms which are remaining, minus 20I plus 10j. So that is the net displacement of the particle from O to B. The average velocity of the particle from O to B would be the displacement divided by time. So the time taken is some 3 hours. So that is what is done here. The displacement of the particle is minus 20I plus 10j, and it is divided by the time taken by the particle, that is 3 hours. So that is the average velocity between points O and B. Afterwards, we are asked that okay, what is the magnitude of the average velocity of the ship between origin and sea. So the point C, how do we find the point C? So the displacement from B to C is how much? So that is the velocity of the ship, that is 5 kilometers per hour, uh, and it traveled with this speed for some 2 hours. Well, that means the ship has uh, taken a different speed, and the total distance traveled would be 5 kilometers per hour into 2 hours, that is 10 kilometers. So 10 kilometers is the net distance traveled, and the direction in which the ship is traveling is j cap, so that is minus 10 j cap kilometers. The overall distance traveled by the ship would be delta r1 plus delta r2, this is this much, plus this distance which is minus 10 j cap, so that will be simply minus 20 I cap. So that means this vector is some minus 20 I cap, and the average velocity would be 20 divided by the total time taken, that is 5 hours. So that would be 4 kilometers an hour. And since we have to only write the magnitude of the average velocity, this much is sufficient. Otherwise, we have to mention that whether this is negative x direction or positive x direction. This was calculated here directly. Next question. A particle follows the path r vector is equal to a cos omega t I cap plus sin omega t j cap. A is in meters and omega is in per second. Find the average velocity, the average speed of the particle between 0 and pi by omega seconds. So how do we do this? So we know that when a particle follows a path which we cannot regularly imagine, we just substitute the values of time. The value of time here is 0 and pi by omega. So let us try to write the initial position of the particle. The initial position of the particle would be obtained by substituting the value of 0 in these two terms. So t equal to 0 in this term would be cos 0, which is 1. So that would be a I cap, and sin 0, which would be 0. Final position would be similar like this. We put pi by omega. The cos pi by omega into omega would be cos pi. So let me just write it how it became: cos omega into cos pi by omega I cap plus sine same term omega into pi by omega j cap. So cos pi is minus 1 and sine pi is 0, so it would be minus ai cap. So the displacement of the particle delta r would be some minus 2ai cap. Now we have to write the average velocity of the particle. So the average velocity of the particle would be the displacement, that is minus 2a I cap, divided by the time taken, which is pi by omega. So this comes out to be minus 2a omega by pi I cap. So this is the average velocity. Next, we have to do the average speed of the particle. So to write the average speed of the particle, we have to identify what kind of motion this is. So this is a circular motion, which you would learn later. So let us take some axis, some x-axis, and some y-axis, and we are saying that the particle is moving in some kind of circle. So the particle is initially at ai cap. The particle would be somewhere here. It is moving along some circle. At the final time, the particle is at minus ai cap. So the particle would be somewhere here. This would be the initial position vector of the particle, that is ai cap, and this would be the final position vector of the particle, that is minus ai cap. The displacement vector would be the final position vector minus the initial position vector which we found. But when we are talking about the average speed of the particle, then if we have to calculate the speed of the particle, then we must know the distance of the particle. So this distance is pi times the radius of the circle, which is a. So this is pi a radius of the circle divided by the time taken by the omega. So this comes out to be omega a. So that is the average speed of the particle in this motion. A particle follows the path r vector is equal to this, find the average velocity. Again, following the same idea, writing the initial position of the particle ri. The initial position of the particle is, we put t equal to 0, then that would be simply 0 vector. And the final position of the particle rf would be, when we put substitute t equal to 1 here, so that would be simply I plus j. Time taken is also 1 second. Then the average velocity vector would be simply I plus j divided by 1 minus 0, that is 1. So that was our discussion on average velocity. Next, we want to proceed towards what is the velocity of the particle at some particular instant. So how do we do that? So eventually we have already learned the definition of average velocity, and in that definition we learned that the ratio of displacement of the particle and the time interval in computing that displacement becomes the average velocity. So why not use that definition to get the instantaneous velocity? And just by decreasing that time interval to such a small time interval that it becomes a single instant. So that is our objective. And to complete that objective, we have to learn a small mathematical tool, which is differentiation. So first, let us identify what differentiation is. The differentiation of some quantity y with respect to x, which is also called the derivative of y with respect to x, is defined as the ratio of change in y and change in x when the changes themselves are infinitesimally small. So this is what we are going to obtain, that how this becomes differentiation, this limit delta x, and why this is differentiation. Okay, so let us look at this graph. So in this graph, what we have done is that we have drawn an x-axis, we have drawn a y-axis, and this is the curve which we are going to study. So we have taken some 2 points A and B on this curve. So the coordinate of these 2 points are already known. The coordinate of the point A is x1, comma y1. These are the coordinates, some x1, comma y1, and the coordinate of point B is some x2, comma y2. So imagine that we have to judge the rate of change of y with respect to x. So what do we mean by rate of change of y? Rate of change of y means that if y changes from a to b, that means its now value is y2 from y1, then the change in y is y2 minus y1. So how much change has occurred in y when a subsequent change in x has occurred? So the corresponding change in x is delta x, which is mentioned here. So this is that is what we are aiming for. The change in y and the change in x. What is this ratio? So if we compare this with the ratio of displacement and time, then that would be very easy to have a analogy. In the case of average velocity, we took the ratio of displacement and time. So when we took the ratio of displacement and time, we got average velocity. So here we are taking the ratio of delta y and delta x, and we are searching what that ratio means. Moving ahead, like we discussed, this is rate of change of y with respect to x, and this is some delta y by delta x. So what I said is that when we have to use the definition of average velocity, we will reduce the time interval to very small values. That means the denominator in the definition of average velocity is going to be becoming small. So now look at the denominator over here. Here the denominator is delta x. So we are going to make delta x very small. So how do we do that? So we take the curve AB, we magnify the curve, and now let us see what is being done here. So in this curve AB, um, this AB is called secant. Secant is that line which cuts the curve, this curve, at 2 points. So when we are talking about delta y by delta x, so delta y by delta x is actually the tan theta of this triangle. If we can imagine this triangle, this line, this line, and this line. Imagine this triangle. Now in this triangle, this is delta y, this is delta x, and this complete angle is tan theta. I hope you are able to see what this angle is. So delta y upon delta x is tan theta. So that is what is written here. Delta y by delta x is tan theta, and this is slope of secant AB. Now things become interesting here. We want to reduce delta x. That was our objective. In average velocity, if we want to find instantaneous velocity, then the time interval has to be very small. That means the denominator has to be reduced. Here the denominator is delta x. So when we are reducing delta x, what we are doing is that we will be bringing b close to a. So this b is brought closer to a. It is brought to b dash. Then it is brought to b double dash. So you can see that the straight line AB is changing. The straight line AB, it was somewhere here. Now it is here. It has changed. It will change again somewhere like this. So it is changing. The straight line, it is changing from AB to AB dash and AB double dash. So as B is brought closer and closer to A, this angle is changing. So our idea is to judge the rate of change of y with respect to x, right? So between points A and B, the rate of change of y with respect to x is simply delta y by delta x. We were bringing B close to A, so that is delta x becomes small. Imagine the case when B becomes very close to A. That means it becomes infinitesimally close to A. In that particular case, when B becomes infinitesimally close to A, then this straight line would actually become a new line which would be touching this curve at a single point. So this would be touching this whole curve at a single point, and this new line is called the tangent to this curve. So tangent is actually a line which touches this whole curve at a single point. Earlier it was touching the curves at 2 points A and B. Now it is, when we have brought B close to A, the points have come so close that it is touching. So the slope of the earlier curve AB shows the average rate of change. The slope of this new curve will show the instantaneous rate of change of y with respect to x. And this is what we are looking for. This is called differentiation. So this is what is written here. As b approaches a, delta x becomes smaller. The slope of secant approaches the slope of tangent at a. This is what we discussed. The slope of tangent at a is the rate of change of y with respect to x at a. So that means that this is what we have obtained when we have reduced delta y by delta x to a very small value such that delta x is very small. We have reduced delta x to very small values. So we put a limit sign on top of it. Limit delta x is becoming very small. So as delta x is becoming very small, this delta y by delta x itself becomes the rate of change of y with respect to x at the point which we have taken. And this is called the differentiation of y with respect to x. So in conclusion, what is differentiation? Differentiation of some y with respect to x is actually finding the rate of change of y with respect to x, and it is equal to this expression. So how do we actually minimize this expression? How do we write this expression in short? So that is written here. So to write differentiation of y with respect to x, limit delta x approaching 0, this symbol means approaching. So we shorten this delta term. What we do is that this delta is written as small d and this delta is written as small t. So limit delta y by delta x is equal to dy by dx. So that's why we say that dy by dx is differentiation of y with respect to x. So what are the different formulas for differentiation? So as we have found that the rate of change of y with respect to x at a single instant, at a single point, is actually the slope of the curve at that point. So that is what these formulas would be representing. They would be representing the slope of the curve at that particular point. So for example, we are taking a curve which is not changing, which is constant. So it would be a curve looking like this. This is y, this is x. The y is a constant. So you can guess that the slope of the straight line here is 0 everywhere. So since the slope is 0, when we would take the differentiation, it would be 0. So that means d by dx of any constant is 0. Next, d by dx of some x. So we draw a line y is equal to x. So whatever is given within the brackets, this is y. And we have to draw that and try to find the slope of that. So y is x here, so it would be a straight line like this. We know that when y is equal to x, it is a line whose slope is 45 degree and tan 45 degree is 1. So d by dx of some x is always 1. Next, there are some common formulas which would be coming again and again. D by dx of a into y. So a the term a comes outside and we have to differentiate y. So this is a common thing which you would remember, that when we are differentiating two quantities a and y, and a is a constant, the constant simply comes outside and y gets differentiated. So that is a into dy by dx. Next, d by dx of x square. So to differentiate that, let's draw a square. Now here y is equal to x square. So that is what we are looking for. Here we are looking for the area of the square. So this particular distance is x, and this particular distance is also x. Let us increase the size of this square. So we do something like this. Okay, so this distance is x, and since it's square, it's also x. Now let us increase the size of the square. So let's say the side of the square is increased by delta x. This side would also increase by delta x. Uh, and if we were to divide this new square into these new parts, this is x, this is delta x, so this is x delta x. This is x, this is delta x, this is also x delta x. So this is delta x square. So if we were to find what is the new area, what is the change in area? A change in area would be these new areas which are developed. The new areas are 2x delta x plus delta x square. Now divide delta x by both sides. So we get delta y by delta x is equal to 2x plus delta x. So we define differentiation as change in y divided by change in x, with the limit that delta x is approaching 0. So let us do that here. Let us put a limit that delta x is very small. So when these quantities are becoming small, delta x is becoming small, this is equal to 2x. So that means d by dx of x square has to be 2x. This is what we found. So this is a useful formula which we must remember, that differentiation is something which is squared with respect to that thing only is 2x. Next, there is a general formula which would come in again. So this is d by dx of x to the power n. So this is equal to nx to the power n minus 1. So this can be easily remembered by remembering that whenever we have to differentiate something which has some constant power, then the power comes as a coefficient and the power itself becomes minus 1. So the power n comes by the side and the power becomes n minus 1. So this is d by dx of x to the power n. Next, d by dx of ax to the power n. So we have to differentiate this. N comes again outside, a won't be, a comes outside and n also comes outside, and the power becomes n minus 1. Next, what if there are two terms y and z, they are being subtracted or added, then what would be their differentiation? Then we can say that dy by dx plus minus some dz by dx. Let's say we have to differentiate ax to the power n plus bx की power m plus c d by dx of this is to be done. So differentiating the first term. So we have taken a outside, differentiating x की power n as nx की power n minus 1, differentiating bx की power m into b x की power m minus 1, and differentiation of c, which is a constant, is 0. So this is what is written here. Now differentiation of trigonometric function. So we have to differentiate sin x. So sin x is differentiated, we get cos x. Differentiation of cos x is minus sin x. So these are the two things which we have to remember. This would come commonly in our study in this particular idea. The further terms given: differentiation of tan x is sec square x, differentiation of cos x is minus cos x cot x, d by dx of sec x is sec x tan x, d by dx of cot x is minus cos x square x, d by dx of e की power x is e की power x. So this would be again something which we would encounter again and again. Now, what if something comes within the argument of a trigonometric function? That means some ax within sine. So this a comes outside as is, and sine ax, sine is differentiated, it becomes cos ax. Similarly, if we have to differentiate cos ax, then a comes outside, differentiation of cos ax is sine ax with a negative sign. Now let us do some common differentiation, differentiating t square minus t with respect to t. So dy by dt, differentiation of t square is 2t. As was we had actually proved that the differentiation of x square is x. So in the same way, differentiation of t square is 2t. The differentiation of 2 square is 2t. Differentiation of t is simply 1 from the slope of the graph. So this is 2t minus 1. Dy by dt of 10 e की power t, 10 remains as is, and e की power t differentiation also remains as is. Find the slope of the curve at respective points. So first we have to differentiate the curve y is equal to sin x. So dy by dx is equal to cos x. We substitute the value of x here. So dy by dx, substituting the value of x, pi by 2 here, cos pi by 2. Cos pi by 2 is 0. So that is what is we have mentioned in the solution of this example, that step 1 is to differentiate and step 2 is to substitute. So that is one thing which we have to remember when we have to find the slope of the curve. Whenever finding a slope of the curve, first we differentiate and then we substitute to find the slope of the curve at that particular point. So if we put the value of the point first, let's say if we substitute value of x equal to pi by 2 initially, so when we have already substituted the value of x equal to pi by 2, we would get y is equal to 1, and differentiation of constant would come out to be 0, which would be same as the answer, but that is not correct. Whenever you would substitute the value first, you would get a constant only, and after differentiating that constant, you would always get 0. So if we have to find the slope of the curve, we have to differentiate the equation first and then substitute the value at which we have to find the slope. Next, we have to find the slope at t equal to 1 for this curve. So differentiating t square minus t, dy by dt, differentiation of t square is 2t, and differentiation of t is 1. This is what we did here. Differentiation of t square minus t. Now we substitute the values of time at which we want to find the slope. So when you substitute t equal to 1, this is 2 into 1 minus 1. Which is next something, uh, some question that find the angle which the slope is with the positive direction of x-axis. So this one you can try at home. Product and quotient rule and differentiation. So these are two rules which are important for us. Till now we have learned that what is differentiation about, finding the rate of change of y with respect to x, or as we would learn further, the rate of change of position with respect to time. That would be also calculated by differentiation. Uh, and the formulas which we have learned up till now would be sufficient for our chapter and the chapters to come. Uh, so moving on, product and quotient rule, we say that when two terms y and z are in product of each other, we have to differentiate y and z one by one. So z is outside. First we keep z outside and differentiate y. When these two terms are in are multiplied, that is, they are some kind of product. So what we do is that we keep z outside, we differentiated y, we differentiate y dy by dx, plus now it is y's turn to remain outside, and then we differentiated z, and we put a positive sign plus in between them. So this would be pretty easy rule to remember. Differentiate one, keep the other outside, plus differentiate the other and keep the first outside. The quotient rule would be rather slightly difficult to remember. There are two terms y and z. So when differentiating something like this, the denominator is first squared, z remains as is, the first term is differentiated minus the first term and differentiating the second term. So this you will learn by practice. Let us differentiate sine square t. So dy by dt or sine square t. So d by dt of sine square t. Sine square t can be written as sine t into sine t. So that we can use the product rule. Let us keep one sine t outside and differentiate the other. So when we are differentiating sine t, one sine t we kept outside and the other sine t has to be differentiated, so it becomes cos t, plus the other sine t is kept outside and the other sine is differentiated, that would be again cos t. So that would be 2 sine t cos t, which is sine 2t. Next we have to differentiate t e की power t to dy by dt. So d by dt t e की power t. Keeping t outside, differentiation of e की power t is e की power t. Keeping e की power t outside, differentiation of t is 1. So that would be 1 plus t into e की power t. So now let us apply the concept which we have learned of differentiation into instantaneous velocity. So like we discussed, we like to define instantaneous velocity using the definition of average velocity itself. That means that we don't want to use a new definition. So what we said is that when we are calculating some average velocity of a particle, so average velocity is some displacement upon time interval. Now when that time interval becomes very, very small, then that becomes the rate of change of position with respect to time at a single instant. So now the velocity of the particle what we are trying to do is that we are trying to decrease the time interval. So that is what is written in the definition. the limit of the average velocity as the time interval becomes infinitesimally small. So this is average velocity, and as the time interval becomes very very small, it becomes instantaneous velocity or the velocity. And as we said, delta x upon delta t is written as dx by dt. So that means velocity is can be symbolized as dx by dt. One more definition which we commonly remember is the rate of change of position of particle with respect to time at a certain instant is called the instantaneous velocity, or simply the velocity of the particle. That means how fast the particle's velocity, how fast the particle's position is changing with respect to time. So that is what we want to focus now on. After uh, uh, after being done with the mathematical part of the velocity, that is what is v. How do we define it? Now we want to think about the physical part. That means we want to get a feel of what is happening here. So as we see in different cases, let's say I have released a ball from some height. So when I am releasing the ball from some particular height, then the height of the ball, it changes very slowly initially, and when it is just about to touch the ground, its position changes very fast. So the measure of how fast the position of changing, how fast the position of particle is changing with time is called the velocity. That means how fast the particle is moving or how fast a particular body is moving. So some common examples can be speedometer of a car. For example, a car is at a red light and then it turns green. So the speed of the car would be 1, 2. It would after some time reach 10 kilometers per hour, 30 kilometers per hour, and so on. For example, you are going to your friend's home and you have a Google map with you. So the Google map shows at which speed, and not only the speed, the direction in which you are going. So the direction combines with speed and it gives you the complete velocity in which you are moving. So this is the judgment which we get while calculating the velocity of the particle, that how fast or the rate of change of position of the particle with respect to time. That is the instantaneous velocity. So let us do one example. A particle moves x per x equal to t square. Find the average velocity of the particle between 1 second and 2 seconds, and find the velocity of the particle at 1 second and 2 seconds. The average velocity can be calculated by simply calculating the final positions. Putting t equal to 2 over here, we get 4. Putting t equal to 1 over here, we get 1. So the final position is 4 minus 1 divided by the time taken, that is 2 minus 1. So the average velocity is total displacement upon total time. To get the instantaneous velocity, we differentiate x equal to t square dx by dt. So dx by dt is sum 2t. And we put values of time in this particular expression. So when we substitute t equal to 1, we get the velocity at t equal to 1 seconds. And when we substitute t equal to 2, we get the velocity at t equal to 2 seconds. That is 4 meters. So this is where we would end this lecture. In the next lecture, we would continue upon this idea, doing some questions on instantaneous velocity and thinking about the next ideas, that is how fast the velocity changes, which is acceleration. Thank you.